All right. Good morning. I'm glad that almost all of you, in fact, I'm impressed, were able to get in on time. Give it a couple more. So actually, that's 11 on the dot. So we'll start. All right. So good morning. Welcome to Applied Calculus 1, Math 261. Hopefully, you're all in the right room. Ha ha ha. My my joke is I don't know. I was gonna say out of taste, but I don't think it's out of taste. It's just a bad joke. Um, I will definitely miss seeing your faces in a classroom this summer. I definitely prefer the traditional teaching style, but when life gets complicated, we have to be strong, move forward, persevere, and make the best of the situation that we can. So I'm hoping that y'all are in agreement with that statement and are willing to put your best foots forward, best feet forward, best foot forward, whatever. um, and do this thing. And there's 8. I think we only have 8 in the class. I think that's everybody. Wow. Seeing some familiar names. And I'm just looking at who's on right now for a second, which you may or may not be able to see. I know it shows up on YouTube, but I don't think it shows up on Zoom Live. I've got a couple of menu options. Like if you just think I'm hovering over Word right now, I'm not. I've got a whole other set of options that I can click on. Anyways, so I've got the syllabus pulled up, and I will show you real quickly how you can get the syllabus, which I already mentioned in the email, I believe, but in case you didn't get the email or in case you signed up since then. So we're going to use 2 kind of sites for the most part in this course. We're going to use Canvas, which is how you get to the Zoom live lecture. And every day when I finish the lecture and I say goodbye, everybody, excuse me, then I wait 10 minutes for the video to process so I can save it to my computer. Then I go to YouTube and I upload it there, and I wait like 10 minutes for that to process. And then after that, I will add another link below where it says Zoom live lecture. It'll be in the same tab, the same module, if you will. That's the name they like to say. So all the lectures will be in this here. So every single second that you hear me talk throughout the semester will be available digitally. Now, I tell you what, I really like that. I love that that's available because that gives you as students so much opportunity to go back. It's an extra study tool. You couldn't do that in the past. I mean, you could if you just recorded the audio, but you didn't have my whole screen, everything I'm doing. You couldn't, it just wasn't as convenient. So that is a massive advantage if you have, technology readily available with you and you are willing to, go back and put in time. Time and effort is most of what this course comes down to, I think, as well as having prior knowledge. So anyways, usually the point of all that being is that when we finish our lecture, 12:30 to 1 o'clock, generally speaking, within 30 minutes, as long as I don't have anything super crazy going on at home, I will have that uploaded to YouTube and you'll see a new link in here. And I put the links up before the video finishes processing. So if you just immediately want to get back into it, you might have a 10-minute period where it says video still processing. So just have patience. But every lecture will go up there as long as they record. Notice I said that. And I'm laughing awkwardly for a reason because last semester, we were doing this for about half of the semester and everything went really well except one time. There was one time where the lecture did not record. I don't know what happened. But it didn't record, so that one was lost. I was nice to my students and I went back and did like a quick summary, but what was originally an hour and a half class, I did the whole thing in like 30 minutes, and it was like, sorry if you missed the live lecture, I'm at least giving you something which is better than nothing. All right, so hopefully that doesn't happen. This is me knocking on my wood desk if you didn't hear that. I'm gonna put up some files in here, just some kind of prerequisites and pre-calc stuff that I also give to my pre-calculus students. It's a lot of stuff like factoring, basics of rational equations, exponent rules, things that we don't really have time to discuss in here. This class has been very padded over time. When I started teaching this class 14 years ago, maybe 15 years ago, no, 14 years ago. I could finish the course in a semester. I have a really, and that was with doing an entire chapters with a review material that wasn't even built into the course. We've added tons and tons of applications. We've added more detailed examples. Things have just gotten really padded out over the years because a lot of things change with teaching math, whether you know or not. So we don't have anywhere near enough time to cover review. I'm going to do a little bit of review today, but when we start back up on Thursday, we're diving into calculus head first. So point being, I want to give you some of those files that I give you my pre-calc students, just in case you're a little rusty and just need to see the basics, some of the basics. Again, things like factoring, exponential rules, whatever, nothing super detailed. However, even though I won't have time to do a lecture, there are, and I can't show it because Mymathlab is having problems today, just like it always does on the first day of class. Even though, well, actually, I guess their servers probably are more bogged down with this internet stuff. So anyways, point being, when you go to your assignments, and it says I have none assigned right now because, well, the thing I just showed you, it won't let me assign them. But if I go to manage, you can see, you can at least see them just without due dates. So there are 7 sections of review material, and there's a couple of things that I'll touch on, as I said today, after we spend like an hour talking about how this course works. I'll touch on some of the more important ones, but not in great detail and not everything. However, there are homework assignments, which are not going to count for or against your grade. This is just if you know that you need to de-rust some, if you need to practice some old skills. Now, do you have to do this immediately? Not necessarily. I'll leave them available all semester because some of these things don't pop up immediately. Like I want to say R6 is on exponentials and logarithms. We won't really see that stuff for what, maybe, I don't know, 5 or 6 classes roughly, maybe longer than that. It's been a while since I taught this class in the summer. I just taught it in the fall. I'm not rusty with the class or anything. I just, going from 16 weeks to 10 weeks, it's harder to think about the schedule off the top of your brain when you're used to the 16. So anyways, point being, I think it's this section. I got my textbook in front of me. I can confirm that. Give me 10 seconds. Nope, too far. I am correct. So the sixth section, say that 3 times fast, covers exponentials and logarithms, which is one of the last things you cover in Math 161. So, maybe you want to go ahead and review this now, and maybe you'll remember it for the rest of the semester, or maybe you wait until you see it in the class's material and go, hey, I don't remember too much about exponentials and logarithms. Let me go back to this section and do some of the homework, because the homework is not just fill in the blank and it's right or wrong. You got things like help me solve this and view an example along the way. Not in every problem, but in most of them, especially in the review chapters, that would be helpful. So again, not covering this material officially, not testing on this material officially, but it is there, it is available to you. I'll give you some extra documents as well. In fact, I can show you what they'll look like. Let me pull up my pre-calc class from last semester because I gave it to them. So this prerequisite material, I'm going to give y'all every single one of these, and I'm not saying that all of this exactly goes with the review chapter. I'm just saying it's stuff that's helpful reviewing. So exponent rules, boom, all the different properties of exponents that you need to have memorized inside and out for all semester, and then some quick examples involving them. It doesn't actually do the math, it just shows you the processing. And then they're not all just pictures. Some of it's a nice long file with some explanations, some little tricks that I use that you might hear me say in class. I'm not here to teach factoring. You are supposed to already be masters of factoring. So again, if you're rusty, you need to practice. Factoring is going to be used all semester. Well, that's weird. Is that I'm going to say this is because it's in the file preview. If I download that, those signs should be there. You see how there's no signs right here? So let's download that and make sure nothing got goofy. Yes, they're there. Oh, that's interesting. Oh, no, I know why they're. So this, ignore me. I'm rushing. I'm not paying attention. This is just the A-B pattern, and then I fill in the signs later. I'm sorry, I wasn't paying attention. I wasn't expecting to pull that up, so that was on the fly. Please forgive me for my quick little mistake. And if you ever hear me make mistakes, please feel free to type it into the chat. I generally don't like having people's audio unmuted or video unmuted for this because weird stuff can happen. Weird stuff usually just being background noise. I tried it last semester and it went terribly every single time. I have a headset mic, so there's not too much background noise, and I've got a what's it called? Not a filter, but a thing so that the volume doesn't peak. So if I cough, it doesn't blow out your ears generally, unless that's on your end and your audio is like that. So wrong one. That's the other window. It's really fun doing this digitally. A little bit of sarcasm. Again, I have no problem doing it. It's just, it makes it more interesting. I'm getting used to doing things. So again, your actual official homework and where we start the course is in chapter 1. So we'll cover 1.1 through 1.8, then we'll have a test on it. Then we'll cover chapter 2.1 through 2.6. I think we're going to skip some of these sections. And these pre-built homeworks, when I used them last semester, oh man, some of these problems were brutal. I don't know what they were thinking when they redesigned this course, but I'm going to have to spend a lot of time this summer editing down these homeworks. And I'm not asking for pity or anything like this. It's just whoever designed this course shell, because we all have our own responsibilities. I designed 154, someone designs 161, someone else does 261. It's kind of like that. But I think they made this like it was an actual real calculus class for science and engineering, and this is more of a business and etc. calculus. So we don't go as intense into the crazy details, and there's some problems in the later stuff that is crazy and intense. So again, point being, I've got to edit down the homework. I've got to water it down. And there might be a couple sections where there's only like 10 homework problems. Now, I'm of the belief that repetition is important for learning math. I never learned something after doing it once. I had to do it 5 times or 10 times or maybe even 20 times. And there's a lot of variability from person to person and topic to topic. Some things will click like that. Some you spend 15 minutes crying in the corner before it finally clicks, and then you're able to start reproducing things 2 hours later maybe. But we learn differently, we process differently, we understand differently. So you need to kind of figure out what your time scale is for this. How much time do you need to be putting into this? And if you think you need to put in 6 hours a week and it's not enough, then put in 8 hours a week. If you're putting in 10 hours a week and you feel like you're oversaturated in it and you're acing it, then maybe you can pull back a couple hours. But you have to understand how much time to put in. Now, I want to say, just up front, I'm just going to type this in a random spot in the syllabus. The expected time put into this course outside class is 9 to 10 hours per week. Now, that is not my rule. That is just the general broad spectrum rule for a 3-credit 10-week class in college. The rule of thumb, which I feel like they don't tell students anymore, is in a fall spring semester when you have 16 weeks, a 3-credit class, you should expect to have to study, which means do homework, review, look back over the material, watch videos again, whatever it is. All that stuff combined outside of class, for fall and spring, for a 3-credit class, you should be spending 6 hours outside of class. Now, again, that's just a general benchmark. Some people who are better at math are only doing 2 or 3. Some people who really struggle, maybe they would need 7, 8, 9 hours. So we're a 10-week summer class. We are accelerating. We have to go boom, 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 2 hours a day instead of an hour and 15 minutes every day. So it feels like we have to do everything quicker, but honestly, it's the same amount of time. It is the exact same amount of minutes in class. It's just done over 10 weeks instead of 16, so it feels rushed. But because of that, quote, rushing, that 6 hours of expected study, homework, etc. time becomes 9 to 10, because we're working 50% more each week, so you gotta take 50% more of 6. Now, why is it that students generally fail their math classes? It's because they're not doing this. Now, at calculus, maybe you've just been passed along and somehow got past pre-calculus for no apparent reason and you're in here and you don't even know how to factor. If you don't know how to factor, you are going to have a bad time in this class. If you don't understand the basic principles of pre-calculus, handling polynomials, dealing with quadratics, things like the difference quotient that you should have seen in that course. We're going to use a lot in the beginning of this course, and we're going to extend it as well. If you don't have that background, if you have the extra time, then you need to spend a ton of time dedicated to working on the prerequisite material, doing independent study, doing those review sections, going to something like purplemath.com or khanacademy.com and really just digging in and getting that stuff, because I'm not here to teach prereq material, I'm here to teach calculus. And I'm sorry for those of you who are in this room right now, this quote room right now, digital room, if you will, who are missing the prereq material because maybe you just got placed into this because of the placement test or your high school GPA and what classes you had, and maybe you had a bad teacher, or, whatever. I mean, sometimes you end up in a place that you're not ready for. But if that's the case, you need to understand that, and you need to take responsibility for yourself and get set up for success. And if it turns out that you can't take this class this summer because you're not ready, then spend this summer developing that prereq those skills, and then take it in the fall. Because I don't want you to fail because of missing information, but I also can't hold your hand, and I can't spend an extra 9 or 10 hours teaching you pre-calculus. All right, so that little fun rant aside, again, you see lots of sections. We really only focus on the first 4 or 5 chapters. We just changed textbooks, so I might be saying that incorrectly. Let me make sure. We might hit the very beginning of chapter 6, but it'll be tough with this new format. I expect that I'm going to have to trim some material here and there. Something that would take me 2 hours in class normally might now take me 2 hours and 10 minutes or 15 minutes with these technological changes, digital virtual teaching and everything. So I just might have to trim the fat a little bit here and there, but I have all the material that you need we'll get to. If I have to cut some basically extracurricular stuff, extended concepts, whatever, then that's what gets cut. Because I know some of you will go on to 300 and 400 level economics classes where you need the basic ideas of differentiation and integration. Those are 2 of the 3 things we study in calculus. We have 3 main topics: limits, differentiation, which are also known as derivatives, and integration. 3 topics that we got 10 weeks to cover. And we don't cover them equally. We do spend a lot more time on the first 2 than the last one. And I'll go ahead and spoil this. The last one is the opposite of the second one. The second one comes from the first one. So they're all connected. And if you can hear my dog barking, I am sorry for that. But it looks like there's a couple children running down the street. So that's the fun of distractions. Hey, there'd be distractions in class too. So it is what it is. So again, I will get these assignments loaded in for you a couple chapters at a time as soon as I can. But as you saw at the beginning, Mymathlab is treating me unfairly, and probably y'all as well. So we just got to wait. I'll also get these extra documents, those prereq material, all 1, 2, 3, 4, 5, 6. I'll put all 6 of those files in our Canvas shell. So let's go back to our Canvas shell. So there'll be a module for that. Let's see, in terms of reviews, let's go back to the syllabus now that we've really kind of finished with that. Sorry, I'm all over the place. Course description, things we cover: limits, differentiation, integration, and a few other words in between. Prereqs, you were supposed to pass Math 161, or it may have been known as 163. If you took it a couple years ago, we changed course numbers at TCC for math. Math changes every 2 years here. It's kind of crazy how often it changes. But you know, people decide what they decide to do, and us teachers, we enforce it and change it. Textbook, Calculus and its Application, 12th edition by Bittinger, Ellen Bogen, and Sargent, 2020, Pearson. So this is a pretty new book. We use Mymathlab. Notice it only says required next to the Mymathlab part. There's also a bundle that you can buy the book and the code, or you can buy the code separately. You have to purchase the code, you have to purchase the code, you have to purchase the code. If you don't purchase the code, you're not going to be able to do your homeworks, you're not going to be able to do most of your tests, if not all of your tests, because I'm going to do most, if not all the tests in Mymathlab. The final might be different. I don't know. I haven't decided yet. We got a long ways to go, and I got a lot of planning. As I said, this is basically starting completely over from scratch in terms of career, arguably. But you don't have to purchase the textbook, because in Mymathlab, right here, eText contents. So, hey, chapter R. What's in chapter R? Let's go to the first section of chapter R. Video presentation. That doesn't sound like a textbook. 24 minutes of stuff. It's got some helpful information in there. They talk about graphing, they talk about this, they talk about that. We certainly don't have time to watch 25 minutes of the video, but you can do that. Or you can view the e-text. I don't know 100% that there's a video. That was weird. It said I timed out and then it let me in anyways. Technology, am I right? This is fun. Where was I? I got distracted. I don't know that there is a video for every single section, but I do know it's there for most of them. All right, so textbook. What is calculus? It's not the junk between your teeth like a dentist might tell you. It's the study of change. So we'll get into that throughout the semester, and they give you some introductions, but you can just say, I want to go to page 5 and hit enter. And now we're on page 5. Or we can use the left and right arrows to go between pages. I don't think you can use your keyboard arrows. You used to be able to, and then they updated the program and that stopped. Don't you love when an update removes a feature? It's not a bug, it's a feature. Actually, it's not a feature, it's a bug. And that must be the last page, or I just froze it. Yeah, I froze it. I swear it's normally not this buggy. I'm telling you, the first day of class is always one of the rougher ones. Either way, you saw the text. I'm not going to waste too much time there. Okay, R.5, video, e-text, study plan. Study plan stuff's not mandatory. That's just more optional material. So let's see, chapter 1. Let's see what 1.1 looks like, the actual calculus, where we'll start next class. Video presentation and e-text. So if you don't like my videos, maybe you like the videos that Mymathlab provides. You know, maybe they're helpful. I can't guarantee that they're going to do the exact same material. I have not watched every single one of those videos. I've watched some, not all. And as I said, I kind of trim the fat on material, so we don't do every single thing they do. Here we go, limits. What's a limit? What's all this stuff? What's that stuff? Why is there a little minus that looks like an exponent for that 1? Why is there a plus as an exponent? These might be things that we'll learn together. These function evaluations, they're kind of tedious. F of 0.9, 0.99. Yeah, blah, 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 blah. It says syllabus right here. I have uploaded the syllabus to Canvas, but not to Mymathlab. If anyone needs it in Mymathlab, email me and let me know. I just feel like if it's in Canvas, that's good enough. I don't really need to upload it to 5, 6 places. So again, the syllabus is in Canvas. Where is it in Canvas? And we're in the course. Home, syllabus right here. Download it as a doc. And then we wait for the download. Maybe my internet is being bad. So I do have a better half also working from home. And I do say better half, not other half. So maybe she's doing something at the moment with Zoom, because Zoom eats up a lot of bandwidth. Okay, there we go. So that's how you get your syllabus. So this is the same file we were looking at earlier. So again, textbook is optional because it's available digitally. I like having a physical book in front of me, but it's not mandatory. I don't want to make you pay the extra money. But you do have to purchase the code because this is how you do your work. You get a 14-day free trial, as I explained in the email. After the 14 days is up, your work is not deleted. It's still there, but you'll have to buy the code in order to get access back. You can purchase the code directly through the Barnes & Noble, or you can purchase it from Pearson, also known as Mymathlab, directly. And I'll show you what that looks like soon, very, very soon. I know that you can be reimbursed if you have financial aid that'll pay for your textbooks. If you purchase it through Barnes & Noble, I don't know 100% that you can be reimbursed if you purchase it from the website. I feel like I've heard students say they were reimbursed, but I don't want to spread false information. I'm not that kind of person. I'm going to say, ask your advisors, ask your financial aid people, talk to them, because I'm not a financial aid person. I'm a math teacher. I don't know all the intricacies of every little detail of TCC. I never have, I never will. It's too much information. It's a lot of information. I can hardly spell well. All right, so Mymathlab. I know I got a lot of you that signed up already. That's my YouTube. That's not what we want. Excuse me. Sign up. So I need to do a new page. Mymathlab.com. So pay attention to this in case you haven't already signed up, which I think about half of you have. So you go to mymathlab.com. You need to register now as a student. This button right here. The things you need: email address, the course ID that I provided over email, which you'll see in a minute, and then either an access code or credit card or PayPal, or just click the 14-day free trial button. Click OK, register now. Type in your course ID, which is Beckner, and then a 5-digit number. It's in the syllabus, it's in your email, you're about to see it right now. 55551. Isn't that fun? Continue. So again, Beckner 55551. On the right, you should see the Math 261 information in my name. I think I hit a button I didn't mean to. That's okay. That's why pencils have erasers. We all make mistakes. So at this point, if you've made a MyMathLab account before for pre-calculus, or maybe this is your second time taking this course. Now, if you took this course when it was WebAssign, you don't get a free second run. You have to purchase MyMathLab code. But if you purchased a MyMathLab code for this course, failed the course or withdrew, and you're back a second time, then you don't have to buy it again. You can just sign in here, and all is good. If you've never used MyMathLab before, any MyLab before, you'll go to create account. Email address. I highly suggest you use your TCC email address. Make sure that you get it correct. It's something like why is it not letting me type? jbob@email. Well, it has numbers too. jbob0001@email.vccs.edu. 2 C's, VCCS. Don't forget the email part. Don't forget the EDU part. If you miss one detail of this, it is going to mess you up bad. Because maybe you go and try and log in with your actual email address, and it goes, you don't have an account. And you go, that's weird. Well, here's my email address, send me a thing. And it still says you don't have an account because you create an account with an email address that doesn't exist. And they can't send an email to an email that doesn't exist. Write down the email that you use. If you use a username that's different, see, it automatically makes it your email, but you can just make it be jbob0001 or whatever, as long as it's available. Write down your username, email, password, put it in a text file, whatever you have to do, because I can't get any of this stuff if you lose it. I think I can get you your username, but that's not helpful, really. It's not going to help you get your email address or password. Security questions, pretty normal stuff. If you're under 18 or in middle or high school, you can click this button and they won't email you, or you can just click this and they won't email you for products and services. Make sure you agree to the terms of service. Now, I can't take you past this page without making a duplicate account, and I don't want to do that. It complicates my life a lot, believe it or not. So after you hit create account, it's going to take you to a new page, and I'm going to draw up what that page looks like. I have a little drawing tablet, which I miss my whiteboard and dry erase markers dearly. I'm getting better with this tablet, but man, oh man, am I not perfect with it. So here is what the next page would look like. You'll have a button here that says, no, not buy, use code. So if you've already purchased it, you click that button to type it. To the right of it, you'll have a button that says buy your code. And I'm paraphrasing, I'm not quoting. And it'll tell you the price, which is somewhere in the ballpark of $100. And then down here in the smallest font possible, it'll say 14-day free trial. So if you don't have your code yet, this is where you click. Now remember, at the end of those 14 days, you're locked out of your account until you buy the code. You have to buy the code. All of your grades are homework and tests, and they're all done, at least almost all of them. Maybe, like I said, maybe the final won't be on Mymathlab. So no code, no grades, no passing grade, ultimately. And again, if you have any questions, please ask. Someone said $75. That is cheap. I have never seen one that cheap before. Wow, maybe they gave a discount because of what's going on in the world or something. I don't remember that one being that cheap. That's awesome. And I know that sounds terrible that $75 is cheap, but man, there's some $300 and $400 textbooks out there. So that's cool. Thank you for that information, and I hope it's accurate. Now, buying it from the online website will be a little different of a price than buying it from Barnes & Noble, because Barnes & Noble takes their 10% markup to make profit and everything, because they have to run. They're not running on dreams and wishes. Oh, someone else said something. What did we say? If we are taking Applied Calc 2, do we need to buy another code for Mymathlab or both classes? I have never seen Applied Calculus 2 as a course in Virginia. I'm not saying that course doesn't exist somewhere in the United States or the rest of the world, but it's the fact that this class is called Applied Calc 1 is kind of a misnomer. At the community college level, it's just Applied Calculus. So again, the 1 is a misnomer. If you were to go to some other school somewhere that was using this same textbook and they were doing the rest of the material from this, if they were calling it Applied Calc 2 and they were using the 12th edition of Bittinger, Calculus, and its applications, then you would not have to pay for it again. But that sounds like an extremely rare case for a class that doesn't exist in Virginia, asterisk, as far as I know. And again, hoping and dreaming that it's the same textbook. So this is probably going to be the only time you use this code in this course. But I know, like our pre-calculus sequence, pre-calc 1 and 2, we use the same textbook, so that code was good for 2 classes. Or when you take the developmental classes, they use the same book, so that code was good for multiple classes. So that's unfortunate, but at least it's only 75. I know the pre-calculus one was more than 100, and I know the developmental one was more than 100. All right, back to the syllabus. Topics covered, you can check that out on your own. Description of assessments and assignments. So like I said, officially we start in chapter 1. We will cover all 8 sections of chapter 1. It looks like we're only covering the first 3 sections of chapter 2. Chapter 3, even though some of these don't say omit, we will be omitting. I love the concept of elasticity of supply and demand, mainly demand, but I just don't know that we have time for this. Implicit differentiation and logarithmic differentiation, we see that we're going to omit one of those topics. Marginals, differentials, and linearization, we might end up omitting that whole section. There will be certain applications that we don't do. We definitely do optimization. I love optimization. It is a fascinating and very applicable topic. I mean, what's the main thing we want to do with our lives? Why are we in school? To make money. What we want to do, optimize our money. If we're a business, we want to optimize our profits. I love optimization. There are classes, graduate level classes, just dedicated to one topic, and they just really get deep and dirty with this stuff. And again, more. Lots of omits. Rough outline of the schedule, and let me tell you, this is very rough. Do not expect this to live up to where it is. This is more just saying, hey, we're covering the sections in this order for the most part. Again, I can't guarantee that in week 1 we're going to cover 1.1 and 1.2. I can't guarantee in week 2 that we're going to cover 1.3 through 1.7. This is just a rough idea. Week 10 will not just be the final exam. I'm sorry, well, no, we do have, I have the week 10 spot twice. What I basically did is I took the 16-week schedule and I just sparsed it out as best as I could into 10 weeks. So we might be a week behind, a week ahead. It feels like we're going to do the material at whatever pace we can. I'm not the teacher that's going to say all these deadlines are the same for all semester because, hey, maybe one day I lose power and I can't teach. Well, we just missed a class. Yeah, maybe one day I end up sick for a week. I get the flu or a cold or something like that, or something happens in my family and I can't teach. We miss a class or two. And those are still possible. If there's a situation where I can't teach live for a technological reason and that my power comes back the same day, and I do have, like you all, I have a busy life, a lot going on, a lot of people to take care of and stuff. If I do have the opportunity to go back and do a lecture and just have it in YouTube, I will, but I can't guarantee that. I will try my best, and it might be a shorter abridged version. I think I mentioned earlier that sometimes I had a video get deleted once and I made an abridged version, but it is what it is. In terms of attendance, if I didn't say this already, you are supposed to attend 85% of this course, which means for summer, you can only miss 3 classes. So if you missed 4 classes, I'm supposed to withdraw you or fail you if it's after the W date. But we're in a weird situation. You might not be able to catch these live. I'm not counting attendance as live. I got to play this by ear. I'm normally pretty big on attendance, and I'd give people a passing day or an exemption, if you will, if they were sick and they let me know and things like that. But with the way things are, you might not be watching live. You might catch a repeat on YouTube, and then you have attended, but I can't tell that. And I don't want to enforce you making comments on YouTube or sending me emails, hey, I watched the lecture. I don't need to see that 50 million times. So attendance is more about homework, participation. If I see a student hasn't done homework for 2 weeks, then they're going to get withdrawn. And 2 weeks is kind of the bare minimum. At 2 weeks, I'm likely to send an email, hey, what's up? What's going on? Because you might just be sick or something. Really sick, something going on. I don't know. But communication is the key. If you're missing stuff, if you're not turning stuff in, send me an email and let me know why. Because again, all I can really do in terms of attendance is say, all right, this student is not doing the homework, so they're not attending. Now, I can see who catches the live lectures, and if all summer, all 8 or 9 of you are able to watch the live lectures every single time, that is freaking awesome, and I love it, and I'll love y'all. But again, as long as you catch it, within a class. Don't wait 3 weeks to watch the videos because you're probably going to miss a test date. You're going to miss due dates on homeworks, etc. Grade policy, standard 10-point scale, distribution of grades. It is definitely not going to be 4 tests. It's going to be 3. So 3 major tests for 20% each. The final exam will be 20% each. Homework and quizzes will be 20% each. Now, this is not a class that I mandate quizzes. Quizzes are generally only when students aren't showing up to class, when we're face to face, or if I just feel like everyone's not doing the homework, I might say, all right, well, here's a quiz to kind of push you to do the homework sooner than later. The Mymathlab, it gives you your grades immediately. When you get a question right or wrong, it tells you you can do a question on homework as many times as you like until you get it right. So there's no reason not to get an 80, a 90, or 100 on your homeworks as long as you're turning them in on time. You will not be allowed to work on your homework after the due date. Again, if you have some crazy circumstance, like you've been sick for 2 weeks or death in the family, you flew to Mexico, I don't know what's going on, but if you have a legit reason and you let me know, then we can discuss an extension. But it's generally not going to happen for something simple like, oh, I missed 1 class, or oh, I forgot. Don't forget. Stay on top of what's important. Communication, email. I had that earlier. My email address up here earlier. It's rbeckner@tcc.edu. My office phone number is up here, but I'm not allowed in my office, so that's not going to do you any good. And unfortunately, I don't feel comfortable giving out my cell phone number. I've already heard plenty of abuse stories from other teachers. And I was thinking about this earlier. I don't know if there's a way for me to digitally access my email, not my email, my voice messages. So if you call that number, you're definitely not going to get me. And if you leave a message, I don't want to say that I can even get the message. I might not be able to. I need to talk to my dean because this has never been an issue before. But email, I think that's just the way to go. Email, email, email. If you ever need to, schedule like a Zoom conference with me to talk face-to-face or voice-to-voice, that's fine too. We can work that out. I have no problem doing that. Back to the grades. So we said 20% for each test. The final is weighted the same. For the chapter-based tests in Mymathlab, I am probably, notice I'm saying the word probably. This is how I did it last semester in the midst of giant mass amounts of change. I was giving my students 2 attempts on the regular chapter-based tests. So, and then I took the best grade. I'm not guaranteeing that I'm doing that all semester. I'm not guaranteeing that I'm doing it at all. I'm likely to do it for the first test. I don't know that I'll guarantee it for the second and third tests. I've got to think about this. I've got to discuss the dynamics about this with some other faculty members because I don't want to be super lenient when other faculty members aren't. I want to be fair. I don't want to have this class be run super differently than someone else. You know what I mean? So I just have to have some communication to make sure that's fair to all students, that I'm not, making things too easy for y'all. And I'm not saying I don't want to do that. I want to make this as plausible and achievable as possible. So we're going to table that idea. We'll get more into that later. So each test is weighted the same as the final is weighted the same as the homework. And the homeworks, you've got tons and tons and tons of attempt to get each problem correct. Homeworks are going to be due 1 week after lectured on. Even if I don't say anything in class, which I generally do. If I don't, it's because I just forgot. So let's say today we finish section 1.1 and 1.2, which we won't. Let's just say I was able to go over 1.1 and 1.2 today on a hope and a prayer. That means today is the 19th. So Tuesday the 26th is when 1.1 and 1.2 Mymathlab homework will be due. And that's by 11:59 p.m. So you get a week and a little bit of extra hours. That's when homework's going to be due. And you may have had me for a class. I know I've got 1 or 2 of you who've had me before where I did homework due on test days. For this class, I don't think that's a really good idea, especially in the summer. It's going to encourage waiting to the last minute, and I cannot encourage that in a summer calculus class. You need to be on the ball with this stuff. So homework will be due 1 week after lectured on. If I don't say it, if I don't write it, it is still assumed. And again, those due dates in Mymathlab are not going to be up until I actually do the lecture in general. And then as long as I can go in and edit it, which I can't at the moment, probably tomorrow. Course communication, if you email me, I will get back to you within 1 business day, which means I'm not obligated to respond over the weekend. If I see it, I will, but I don't always check my emails over the weekend. Maybe once. Very often I can't even check it. I go some places that don't have good Wi-Fi or cell phone service, which I have T-Mobile, which means I can go 5 minutes outside of Hampton Roads and I don't have cell phone service. Yay, T-Mobile. But it's cheap. Anyways, I will check my email from my phone, but I don't respond to it. And I have only one reason for that: autocorrect. Autocorrect and Outlook, they seem to hate each other, at least with me and my thumbs. I can text pretty well without autocorrect making me sound silly. But every time I try and respond to an email, autocorrect just eats me alive. And I won't do it unless it's an emergency or it's a yes or no question. So what happens sometimes is I'll read an email, and then I get 50 more emails and 50 more things in my life happen. And the next time I'm at a computer, I've forgotten to respond. So if you don't hear back from me within a business day, just shoot me an update email. Say, hey, Mr. Beckner, what's the status on this? I haven't heard back from you. Always make sure that you say the title of this class in the email title. Please make sure you put Math 261 because I'm teaching another course. And thankfully, it's not a regular semester. Things are very light this summer in terms of teaching. I've got other things going on. I actually have to do online certification because I'm not certified, and this is online. So I just want to make sure all my bases are covered and I don't lose a job, right? So I'm going to be spending a ton of time doing that this summer. I've heard it's a year-long thing, and I've got to get it done in 10 weeks. So if, like I said, if you don't hear from me within a business day, just shoot me an update, and I'll be like, oh, yep, sorry, I saw that and I forgot to get back to you, or I was busy at the time, whatever. It's not intentional. You can email me, the rbeckner@tcc.edu. You can send me messages on Canvas. Sometimes it doesn't tell me when my inbox has a new message, though. I know there's supposed to be a red little number with a 1 or a 2 or 3 above it. And I don't know why on this computer I'm using, which is borrowed because my computer can't even handle Zoom. It's so old. It doesn't always show that I have emails. I've had that happen at least 5 times. So, I'm not guaranteeing a business day on Canvas. Email me at rbeckner@tcc.edu. Make sure you put Math 261. Math 261. This course used to be called 270. I think I said earlier the numbers changed a couple years ago, and I'm still stuck in the past apparently. We talked about attendance, how it's kind of sketchy in enforcement, but if I just don't see participation at all for 2 or 3 weeks, then you're going to get withdrawn. There's no late work or makeup work unless you've got crazy extenuating circumstances. I will not guarantee making up an exam. If you come to me a couple days after a test date has finished and say, I missed this because I was ill, what I usually do is I'll say, all right, well, the final exam will be a replacement grade, or maybe something else. But again, not guaranteeing. I do that on a case-by-case basis. It really depends on what happened with you and how much communication I've had with the student. It really depends. Don't email me the last day of class, the last week of class, asking for extra credit opportunities. This is not high school. I don't do that. I'm not going to go and just open up a whole bunch of assignments for you. Again, this is not high school. Zeros do not just magically become 60s because you're in a high school class. That is not the way college works. That's not the way the real world works, unfortunately. Some people have been pampered a little too much, I think. Classroom behavior, not really an issue. Electronic devices, not really an issue, except you're not supposed to have cell phones for testing. I don't care if you have it for homework or while we're in class. You might be using your cell phone for class to watch. I don't know. But no cell phones for testing. If I didn't mention earlier, I have the option to require you on Zoom for testing. So you have to have your cell phone propped up so I can watch you test or watch the rerun, watch it live, whatever the case may be. And I won't do that for all the tests. The final exam is likely the only one I'll do that for, just because I feel like it's a limitation. Inclement weather, the only issue I have here is if we lose power, I can't teach. If I lose power mid-lecture, if we have like some crazy windstorm happening, and this happened twice last semester. Well, not during, but it happened before class. But if I lose power during the lecture, the video is gone and it doesn't exist. I'd have to go and redo it again, which I'm likely not going to because I'd be catching up with a million other things. But last semester, I lost power twice because we had windstorms. I live in Churchland, the Churchland part of Portsmouth, which if you don't know, is the land of pine trees. I have 15 in my yard alone, and pretty much every windstorm we lose power and it doesn't come back for another half a day. I lost power for 2 full days, in fact, back in, what was it, March or April? I think April. And then when I got power back, I didn't have internet for another day. That's right. That's what it was. That sucked. So that's basically the only inclement weather we really have. If it's a situation where you lost power but I didn't, the good thing is the video will be on YouTube for you later. So it's more about me. That sounds selfish. I know I don't mean it that way, but it's my conditions that are the most important for that there. If you, oh no, it's not yet. Withdrawal policy. Here's your withdrawal deadlines for a refund. It's May 28th. For the W, it's July 1st. If you try to withdraw after that, they're supposed to give you an automatic failing grade. You'd have to have extenuating circumstances like I'm moving to Canada, which they might even say, if you're moving to Canada, they still got internet there, finish your course. If you were like 8 or 9 months pregnant, that would probably enable you to withdraw after the date, but you really do need an extenuating circumstance for that detail. Sorry, I'm drinking some water if you heard that. Academic integrity, do your own homework, take your own tests. You're not going to learn anything otherwise. There's no reason for anything like that. Follow the testing rules. Homework rules are pretty open. You can use your textbook, you can use your calculator, you can use the internet. There's great resources available. It's really just that for testing. If I think that there's some funny activity going on, I reserve the right to go back and give you a quote oral test, have a conversation with you and have you talk to me about, why this is this and why that is that. And if I find that you can't do the material, then we'll have to, approach a situation that we don't want to have to approach. So let's be responsible adults. Let's be honest and genuine. Plagiarism, academic misconduct, same stuff. These syllabi are so long. Educational accessibility. If you have a document from them for me to check out and accommodate you in any way, I will absolutely do that, but it has to be through TCC. If you have some private doctor who has a form that says you need this and this accommodation, I legally can't do anything about that. You need to go to TCC and get that straight. And once you do, I will accommodate you in every way it says. If it's something like extra testing time, I would appreciate you if you remind me at least for test 1 about it, because with so much going on, I'm likely to forget. And that's not intentional. I want to give you everything that you need. Emergency procedures, not really an issue. Library, not really an issue. Learning resources. I know in the spring, the tutoring center was available digitally. I can't guarantee that at the moment. We actually just sent out an email this morning or last night asking if tutoring was going to be available this summer. I have no idea currently. When I have that information, I will disseminate it to you. I mentioned these sites earlier, Khan Academy and Purple Math, and I think it's actually KHAN. I don't know who misspelled that, but they did it on all the syllabi. I use a syllabi builder that it kind of just extracts things like that. But if you're rusty with your pre-calc, these are 2 great sites to go to. Even if you're rusty with stuff that's not pre-calc, even if it's just basic math, adding, subtracting, multiplying, and dividing, signed numbers, fractions, decimals, those are skills that you're supposed to have without a calculator. If you need a calculator to do 3 minus 4, that terrifies me. If you need a calculator to do a half plus a fifth, that terrifies me. Those are skills you need. Because a calculator, let's say you add, a half. Hold on, I want to make sure I'm doing a problem that would come out the way I want it. Yeah, that should be fine. Yeah, if you did a half plus a third, that would be what, 0.833333333. And nowhere is that a correct answer in Mymathlab or for me. Because if you took 1/2 plus 1/3 in a calculator, it gives you 0.83333. Now you might say, well, Mr. Beckner, that's 0.83 and then a bar over the 3. Now that's technically correct, but Mymathlab is probably not going to want that answer. It gave you math and fractions. It probably wants the answer in fractions. So that means you got to know how to do that. Now, some of you might be clever or just have technology and you go, well, my calculator, I can do this and that and actually display the answers in fractions. And in that case, you're lucky. But not all calculators have that ability. If you don't have a physical calculator, you can download a TI-83. If you just Google, I think, digital TI-83 or virtual TI-83 or download TI-83, you can download this. And there we go. You saved yourself $90. You got a graphing calculator. 5 minus 6. I have no idea what this is. -1. Man, your math teacher should be smarter than that, right? If you for some reason have a lot of knowledge with these things, though, they do clear the RAM every time. That really won't matter for us, though. Back to the syllabus. Already an hour in. I'm gonna check your emails every day, every business day. If I know I won't be able to teach a class ahead of time, I will email you and let you know in advance. If I wake up and I feel ill, since our class starts at 11, fortunately, I should be able to get a message to you by then. I would also I would change what it says in Canvas. So if there's ever a day, wrong thing. If there's ever a day I have to cancel class, when you're in your home menu, of Canvas, when you see the Zoom live lecture, you'll see a note here. It'll be in all caps, no class today, and I'll send an email and I'll make sure everyone's aware. All right. What can I do? So what do your homework assignments look like? Let's go back to, I gotta go to an old semester. So here's my old shell, just so we can actually look at the assignments, since none of ours are loaded and I literally can't do that right now. And we wait. And we wait. Jeez. Somewhere a teacher that retired and all they ever did was chalkboard and or dry erase is laughing right now. Pencil and paper days. There was never a loading issue there, but you also didn't get feedback on your homework immediately. Pros and cons. And now it's not even gonna. Okay, let's maybe sign in again. You can do it. There we go. That's a little better. So let's just pull up one of these. So write interval notation for the given graph. Why did it re-upload? All right, so I have no idea what interval notation is. The answer's 4. Check the answer. Nope, that was wrong. Maybe it was 5. Check the answer. That was wrong. Maybe it's 5. Now notice it says final check. Generally speaking, you get 3 attempts on a problem. If it's a drop down menu, you might only get 1 attempt. And on the final check, if you get it right or wrong, it tells you what the actual correct answer is. Then you can hit this button, similar question, and if you go to the next one and come back to it, the similar question would be where it says final check. If you hit similar question, and let me show you that other case, next question, that goes to number 2. Well, I want to go back to 1. Now that's here instead of final check. So pay attention to this graph. This parenthesis starts on the -6 and goes to the 9. Similar question. Now that changed. It's the same type of problem. It's the same exact concept, but with different numbers. So then you can go, oh, okay, well, shoot, maybe I should actually hit this question help button. What do we have over here? Help me solve this and view an example. So help me solve this. We'll actually take you step by step and ask you to put info in. So the shaded area runs from -4 to 1. Okay. All right, that's good. I got that part right. Interval contains all real numbers between the left and right endpoints. Use parentheses to indicate that an endpoint is not included in the interval. See, these are parentheses, which means the interval notation will also be parentheses around the numbers. There's also brackets. We'll discuss that later, what a bracket would be used. Does the shaded area include the point -4? So this parentheses means it's not included, so you can go no. Cool. Does it include the 1? Well, that's a parentheses, so no. A bracket would. So the interval that describes it should be, well, that means it's parentheses -4, 1. And I got it right. And that's all the questions, so we can hit close. Now, when I hit close, look at how it's going from -4 to 1 in the original problem. We just answered that. But because they dragged us by the nose, so to say, they don't want to give us credit for that. So when we hit close, it changes the numbers again to something a little different. But hopefully in that process you learned, oh, okay, so parentheses, -4, 2, that looks pretty good. We can check our answer, and we got it right. And then we go to the next one. Write the interval notation for this one. Well, I must have done that in another class. I am in the old semester. Kind of funny, I picked the same section. Now, let me get one that's not multiple choice, please. Here we go. Now, this one, -3 and 6, pay attention to those numbers. Now, let's say I just go straight to this, and he goes, oh, wait, man, there's no ask my instructor or view an example. So that means you're going to have to do a little more digging or maybe go back to another problem. They don't all have it. So let me go back to one that does have it and show you what would have happened. So let's hit similar question. It actually gave me the exact same numbers. That's funny. All right. Save best score. Make sure you do that if you redo questions. Hit similar question. There we go. Now I got different numbers. The point of this is if I go to view an example, when I did help me solve this, it asked for my input along the way, and then it changed the original problem. View an example gives you a different problem and just states what happens along the way, gives you the answer. And what that does is it doesn't change the original one. So use what you feel more comfortable with. If you think you need to be typing things along the way, help me solve this is better. If you think you can just read and then reproduce what was done, view an example is good. You've got video, you've got textbook. The Ask My Instructor, I really don't like to use. If you ask me 1 or 2 questions throughout the semester, I'll answer them, but I don't want you asking 50, 60 questions. You need to be doing this more on your own with what's available, because that's the point of homework. So we said that homework's due within a week. The one thing I did not mention, just go down here. That's fine, whatever. At the end of the semester, about 10 points will be added to each homework grade, but a max of 100%. I'm not going to give anyone over 100 on a homework grade. That is not going to be reflected in Mymathlab. Do not trust the Mymathlab grade or average. If you do one homework all semester, if you never touch the rest, if you got a 95 on that one homework, Mymathlab is going to tell you have a 95. It doesn't account for zeros if you never open the homework. It only accounts for zeros if you open them. But guess what? In my grade book, I account for those zeros. So if you want to know what your average is, you are calculus students, you should be capable of adding up 10, 12, 15, 20, whatever, how many numbers are, and then dividing by the number of grades. This 10-point addition will not be reflected in Mymathlab. It would take me days to do that for every single student, even with this small class of 8. I just use Excel. I load up every single one of your homework grades with an Excel file that I download in a couple of minutes. I program some if-then statements, and voila, it adds 10 points as long as it doesn't go over 100. And again, roughly 10 points. It may be 9 points, it may be 8 points. I base it on what the average of the class is by the end of the semester, a certain number I want to hit. And that number is statistically, or let me just say usually, probabilistically, usually in about 10 point of a margin where I want to be. And this is because some of the questions are a little too hard, but I leave them in there for the students who want to go above and beyond. Sometimes you might have a question where the answer is 4.9, and you type 4.8 and it's wrong, and then you do another one and the answer is 7.3, and you do 7.4 and it's wrong, and you do another one and the answer is supposed to be 2.8 and you wrote 2.9 and that's wrong. Clearly, if this is a calculus problem, you got something going on that's right. It's just you're rounding incorrectly. It could be an application where you're supposed to round in a unique way, and there's plenty of applications like that where you round weird. But anyway, so this is just me padding the grade a little bit for things like that, because homework is still supposed to be, effort. So if you have a homework grade that's an 88, let's say I choose to do 10 points exactly. That means at the end, that homework in my book is a 98. If you have a grade that's a 10, in my grade book, it's a 20. If you have a grade that's a 99, in my grade book, it's a 100, not a 109, a 100. I only take it up to 100. So 90s turn into hundreds, 91s turn into hundreds, 95s turn into hundreds. Anything under a 90, you definitely get the 10 points. Again, don't trust what Mymathlab says for your average. The weights aren't set up correctly. The zeros aren't accounted for. Just use the fact that homework is 20%. All tests are 20%. So if you have your homework average, you can then just add however many tests you've got, divide by 2 or 3 or 4, and boom, there's your current average. It's pretty easy to do. Unlike my quantitative reasoning course where we have things weighted 15% and 10% and 5% and 20%. And we already said that homework is due in a week by 11:59 p.m. We mentioned that already. Just saying it one more time. I think that's it for the syllabus. Again, if you have any questions, please post them in the chat, and I'll get back to you in a second. Just scanning one more time through this long document. I remember when these things were only a page or two. And then politics. Okay. One more thing that I need to mention if I didn't already. We have a question. I may have stepped out, but when will homework appear in Mymathlab? As soon as Mymathlab stops being mean to me. It's just a matter of it's being weird today. I'm going to check back on it later today. I'll check back on it tomorrow. I'll check back on it Thursday. I'm going to assume that I'll be able to get everything up by tomorrow. Usually it's no longer than 24 hours where these weird server issues are going on. Darn it, I just forgot what I was about to say. That's my fault. I got distracted. Homework. Did that. Sorry, give me like 20 seconds. I'll figure it out. Oh, now I remember. Okay. You must enroll in Mymathlab before 1 p.m. Thursday, the 21st, or be withdrawn from the course. Asterisk, 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 asterisk. If you try and Mymathlab won't let you in, please email me and I will forgive this. I don't seem to be having any issues. The only issue I seem to be having with is the assignments. I was practicing earlier. I showed y'all how to log into the course and everything, and that seemed to work. So I'm crossing my fingers that there's no problems with that. But just because I don't have that issue doesn't mean you don't. Now, don't lie to me and just say I didn't. Don't skip the 5-10 minutes worth of effort and say, oh, I tried 50 times and never worked. Just do it. It's 5 or 10 minutes of your life. If you can't take that 5 or 10 minutes and do this before next class on Thursday, my point is, how am I supposed to trust you to stay on top of homework all semester? And I don't want a student who can't handle a simple task in when the tasks are only going to get much more complicated immediately after today. So please enroll today. I know half of you already have, and that is excellent. I'm hoping that the rest of you do it today. If not, tomorrow. If Mymathlab gives you a problem today, try tomorrow. If it's still giving you problems tomorrow, try before 1 p.m. on Thursday. If you're still having issues then, which I highly, highly doubt, send me an email. Mr. Beckner, I tried, it's not working, and then I won't drop you. But I will drop you. I'll delete you. It's not technically a withdrawal. It's a deletion. That means you were never here. You never participated under the minimum standards. I think you get a refund on the class, and then it just disappears on your transcript. It's like you were a ghost. Okay. So that is the course. That's our expectations. That's how everything's going to play out. You have to watch the lectures. If you can't catch it live, catch the repeat. You can go and watch the repeats again. Those videos will be available to you in Canvas. I'll also have a playlist set up in YouTube. You can make comments and questions on the YouTube files, videos. And yeah, if you're really rusty with your pre-calculus, I don't have my spring semester's pre-calc class hidden on my YouTube page. So you can find that playlist, but it's only the last half of the semester, so I can't guarantee that's going to help you. But I can tell you that a lot of people are really rusty with exponentials and logarithms coming into this. So maybe you go to my YouTube page and find my discussion of that, which was really quick because we had to rush. It was a 12-week course and we lost a lot of time because of the virus. But you might be able to find something helpful. And you'll have my notes in there that are scanned and everything. So that's good. All right. So with the time we have left, or at least some of the time we have left today, let's talk about some of, but not all, of those review topics. We'll definitely get into interval notation. And yeah, so let me open a new file. If I didn't mention, I have this, yeah, I think I did, drawing tablet. Handwriting's not the best. I do what I can. Using a Word file, it has an algorithm that cleans up my writing a little. But if I'm trying to do this on another thing, if I use this annotation, I literally did nothing, but you can see the difference in that. The downside to using Word is it crashes. I have it crash, I want to say like every other day, which means just 2 or 3 minutes of class time lost, but man, that looks so much better. So I prefer using that. Plus, if I use this annotate, the red stuff, I can't scroll my screen anymore. I have to completely erase it to be able to, and then go off of this thing, and now I can scroll again. Whereas if I use Word, there's no issues, there's less clicking and everything. So it is what it is. All right. Sorry, I'm just moving something. So basics of graphs. We have our standard coordinate system. When it's important, I'll get a ruler out, which is extremely difficult using a tablet flying blind. I'm looking at a screen and I'm writing on a tablet, and it's not a tablet that has a screen. It's just a black slate. So if I try and do a line, like if I want to hit, let's say I want to do a line between this point and this point, just connect the dots, I have to put my mouse on the first dot, take my phone to it, make sure I don't pivot that spot, then take my pen and put it over the other one at the same time, then moving. I'm using my phone as a ruler, if you didn't catch that. And that worked really good until I came off my phone, and you can see what happened. Point being, please bear with me when we're doing anything with graphs. I will do the best I can. I already don't have good handwriting. Using this blind technology makes it more of an adventure. So sometimes I'll just try and spitball it, a little better. So x-axis horizontal, y-axis vertical. If you wanted to plot the point, let's say 3, 5, the first number is how far left or right. The second number is how far up or down. We have our negatives to the left, our positives to the right, negatives below, positives above. So 3, 5 is just going right 3 and up 5. I don't have to label every hash mark on an axis. I can just do that, because if that's a 5 and I see 5 marks, I know they're going 1, 2, 3, 4, 5. And then let's have another point. Let's have this one be -2, 4. So I got to go left 1, 2. I'm doing my best to keep these evenly spaced. That's -2, -1, -2, 4. That would be right here. And then let's say connect them to form a line, which means connect and extend. And I'll do a different color. So I'm just going to do this without a ruler, without my phone, as best as I can. Actually, that's pretty good. It's pretty good. Sometimes my palm catches a little more on this slate. Fortunately, there's an undo button. There's a line. That's a graph of a line. And then with that picture, we can see its slope. We can interpret intercepts, all sorts of good things that we can do. But normally, you're not just given 2 points. You're told to graph a line, maybe something like 2x plus 5y is equal to 10. And you have dozens upon dozens of ways to graph this. You can use random points. You can use intercepts. You can solve for y and use, sorry, not point, slope-intercept. Method. And there's hundreds of methods after this, maybe not hundreds. There's more methods in this, but these are like the 3 ones. So when I say random points, I don't say you just get to pick the point -2, 4. You only pick an x or a y value. I really like the intercept method for this one because it's not solved for y. Intercept method means start with a table, and that's not a question mark, that's a colon. Start with a table of values that looks like this. So the black numbers are what we start with. One time I'm going to let the x be 0. One time I'm going to let the y be 0. So when you plug that in, you plug it into the original equation. I'm going to plug in the x equals 0 first. So that's 2 times 0 plus 5y equals 10. 2 times 0 is 0, so that's just 5y equals 10. And then you'll divide both sides by 5. I don't always show this much work in a calculus class or basic stuff, but it's an intro day, and we get y equals 2. I'm going to put that number in blue. So we started with the 0 and we found the 2. The cool thing about lines, and this is not true of all equations, if you plugged in y equals 2, you'd get x equals 0. All right, now let's try plugging in the y equals 0. So that's 2x plus 5 times 0 equals 10. 5 times 0 is 0, so that goes away. We get 2x equals 10. Divide both sides by 2 to get x equals 5. So that point is 5 comma 0. This is a table of values. That's the same thing as having points 0 comma 2 and 5 comma 0 as coordinate pairs. Nice thing about intercepts is they're going to be sitting on the axes. So 0 comma 2, that's left or right 0 and up 2. There's our first point. 5 comma 0, that's right 5. 1, 2, 3, 4, 5. And up or down 0. Connect with a line. I'll do this with an orange. I'm going to do the best I can, best I can, best I can. Mymathlab, all you do is just click the 2 points using the line feature and it'll make that for you. It's kind of nice. There's a graph. All right, as a reminder, slope-intercept form. Let me go back to black. I also have a button on my pen that makes me mess up occasionally. Slope-intercept form of a line is y equals mx plus b. This is probably the most favored form of a line because it's solved for y, which means it's easy to plug in x values. It's set up as an input-output function. So you're putting it in x's and you're getting out y's. And the number in front of the x, this m, is your slope. It tells you how steep it is. And this b right here, this is your y-intercept. And it goes 0 comma b. It's not just b, it's 0 comma b. In other words, if you plug x equals 0 in, if you plug 0 in here, this whole thing would go away. And all you're left with is a y value of b. So plugging in 0 for x gives you a y value of b. I really wish the undo would stop doing that now. Oh well. So slope is rise over run, which is a formula is y2 minus y1 over x2 minus x1. If you forgot those, remember them. There is not a day in calculus where we don't need this in our brains. And I'm not saying we use it every day. I'm saying you need it every day because you might need it today. You might need it tomorrow. You might need it Thursday. You might need it Sunday. Prereq knowledge means you're supposed to know it, not learn it in the class and then forget it. That makes it fun, right? That's the challenge of math. When we teach you how to use a period in English, we don't expect you to forget it in the class where you're learning what a gerund is. Now, this class is all about the study of change. Slope is the first basic concept of change. So this right here, this is what sets us into calculus. This right here, this is change. It's a rate of change, in fact. Rate means fraction. Change means difference. Change, change. Old, new, old, new. Let's say your slope is equal to, and I want to do this in different colors, which makes it fun to type out. A over B. A, B. There we go. All right, let's talk about B first. This is what we call the run. This is how far you go to the right. Never left, only right. A, the top, is how far you rise. That's up or down. Oops, spelling is hard. How far up or down based on the sign. Up, positive, down, negative. So in other words, if you have a slope of, say, 2, let's go 2x plus 3. Let's graph the line y equals 2x plus 3. So you could do random points. You can plug in x equals 0 and x equals 5, or x equals 1 and x equals 2, or x equals any two numbers you want in the world. Find the y values, plot the points. You could also plug in y values and find the x's. You could plug in an x and then a y. You could do the zeros like before, but it's not my favorite method because the variables are on different sides. I like this slope-intercept method. So we know our slope is 2, but the slope needs to be a fraction so you can see the rise and the run. So that's 2 over 1. The bottom tells you how far right to go. The top tells you how far up or down to go. This is a positive 2, so up. Now you don't start at the origin though like you're graphing a point. This is going to be from any given point. Well, we have the 3, so our y-intercept, the b is 3, which makes the y-intercept 0, 3. Intercepts always have a 0 opposite the name. So an x-intercept has a y value that's 0. A y-intercept has an x value that's 0. And if you look at the graphs, that makes sense. So we're going to plot 0, 3, then we're going to rise and run the respective numbers to get a second point. So I don't have to plug in x equals 1 or x equals 2 or x equals 10 to find another point. I need to insert a new page. Please work. I need to remember to hit enter a lot because Word is funny. Yep, that screwed it up. Let's see. Sometimes this will work. Sometimes it doesn't. Ah. Sorry about this. Maybe. Frustrations. It might just be out of order now. Why won't you let me highlight everything and move it? I know I've done this in the past. Yeah, it's just moving everything lower and lower and lower. Still pushing it. Okay. So we're going to graph this, 2x plus 3. We're starting at 0, 3. And then from that point, we're going to go right 1 and up 2. So I'm just going to rewrite that information here. Where are we? Here. So y equals 2x plus 3. So we had the point 0, 3. That was our y-intercept. And the slope was 2 over 1. So we go right 1 and up 2. So we had the 0, 3, which is here. It's on the y-axis. That's what makes it a y-intercept. To be on the y-axis, you have to go left or right 0, which is why the x value always has to be 0. Now from that point, I'm going to go right 1 unit and up 2 units. So we're going to go right to 1, and I'll show the movement with little dotted lines. So this is me going right 1, and then we go up 2. Now I need to mark 4 and 5 on this to be able to go up 2. So up 1, up 2. So right 1, up 2. There's our second point. Then we can connect them with a line. Nope, that's going to be bad. Let's try again. There we are. And there's our line. That arrow is a little ugly. So that's how we can graph using intercepts and slopes. Do you have to know that? No, but it's a great option to know the 3 primary ways of graphing lines, because we're going to be doing a decent amount of graphing throughout the semester, and lines are not what we're going to be graphing. We are going to graph some curves, and they're going to get more and more complicated as time goes. All right, so that's what I want to cover from section R1. There's more material. Look at that homework once it's available if you want to work more on it. Let's go domain and range. So now we're in the second section. Oh, come on. I have all these other pages and it just keeps doing this to me. Whatever. Sorry about that. I'll make sure this is set up better next time. Domain. These are your inputs. Generally, your x values. Often listed in interval notation. Range. This is your outputs. Generally, y values. Now, unless we're talking apples and oranges, we're talking dollars and quantities of items, we might not call them x and y anymore. We might give them more appropriate names. But when we're just dealing with your basic algebra and calculus principles, x is input, y is output generally. And then range is also often listed in interval notation. Functions have a certain condition. To be a function, no input may lead to more than one unique output. Oh, I don't want that color right now. Back to black. So I said often listed in interval notation, not always. Let's just say for this one, for this example, find the domain, the range, and if it's a function. I'm going to do this just as a table of values. This is kind of a unique problem. Something that we will not typically do in this course. So let's say we had x values of 0, 1, and 2, and then y values of 4, 9, and -6. And then another point, 0, and 4. The domain of this one, because these are finite elements, you do curly brackets, 0, 1, and 2. I don't need to list the repeat. You just list them each once. The range is 4, 9, and -6. They don't even have to be in order because of this type of problem. Now, when we're talking about regular functions that are continuous, their equations, things like that, this would not be okay. It would go to interval notation. This is not interval notation. Is it a function? Well, to be a function, no input may lead to more than one output. This point and this point are potential issues because it's the same input. But look at this. The outputs are the same each time. So yes, this is a function. It's okay to put in the same input and get the same output every time. What's not okay, spoiler alerts, is this. I'm going to skip the domain and the range. You should be able to do that on your own. The domain admittedly doesn't change, but the range does. But is this a function? Well, we have the warnings here. The warning is the fact that you have repeated inputs. That's a warning. It was a warning last time, but the outputs matched. This time, these are not the same. I don't know why I have 2 S's there. Just ignore that. This is one input having more than one output. So no, that's not a function. For graphs, we have the vertical line test. Any vertical line may only cross the graph at most once to be a function. Again, I know I'm going quick because this is review material. But let's say, here's our graph. We got a parabola. So I have to be able to draw infinitely many vertical lines on this, and all of them touch the graph only once each time. Or none is okay. That one touches once. That one touches once. That one touches once. And if I do that a million times, you would see that, yes, that is a function. Let's take that parabola and tilt it on its side, though. Now, I can draw vertical lines on the left side. All of these are 0. These don't touch it at all. They're perfectly fine. So someone might say, yes, this is a function, but you have to consider everything. If you do this right on the y-axis, ignoring my graphical error, that would touch the graph one time, and that's okay. So the left side's perfectly fine to be a function, but anytime you do this on the right side, which you have to consider everywhere, boom, boom, that touches twice. So no, that's not a function. Function notation looks like this. F of x equals blah, 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 where blah, blah, blah is something like y, like 2x plus 3, 5x minus 7, x squared plus pi x minus 11. I almost said 11d for fun. That blah, blah, blah can be simple or complicated, but can only have x's. This is basically the same as saying y equals, but with some added features. We can plug in anything to functions, not just numbers. But if you had y equals, you can only plug in numbers. So if I have y equals 2x plus 3, I can only plug in numbers to that. If I have f of x equals 2x plus 3, I can plug happy face into that. I can plug sky into that. I can plug 42 into it. Function notation is better as well because it shows inputs and outputs in answers. So let's say we had y equals 2x plus 3 versus f of x equals 2x plus 3. Same thing on the right side. And I say evaluate at x equals 1. Well, for the first one, you go y equals 2 times 1 plus 3. I'll do a different color for showing the plugging in, which when you simplify that, 2 times 1 is 2, 2 plus 3 is 5. So you get y equals 5. That's your answer. If you do it this way with function notation, the input goes where the x was. So this would be f of 1. I'm just going to go ahead and put the 1 on the right side for time's sake. And that would be equal to 2 times 1 plus 3. 2 times 1 is still 2. 2 plus 3 is still 5. So we get f of 1 equals 5. In the first version, you only see the output. Here you see the in and the out. You see the full coordinate pair of 1, 5. Now you might say, well, Mr. Beckner, I don't need function notation. It only took me a step. I can see the input right here. I plugged in 1. Well, maybe this isn't a simple problem. Maybe it's lines and lines or pages and pages of work. Maybe your dog goes and eats all your work but leaves the answer. And I go, well, what'd you plug in to get your answer? Well, if you use function notation, you're staring at it. If you don't, go and do the problem again, right? Or maybe you just missed your points. I don't know. So that's our function notation. And again, we can plug in all sorts of things. We can do, instead of just doing f of 1, let's use that still. Let's do f of z. So I'm plugging in z. I put little lines in the middle of my z's to distinguish them from 2's. So that'll be 2 times z plus 3. Now I can't actually do anything to 2 times z plus 3. So f of z is 2z plus 3. Your answers can actually be polynomials and rationals and radicals and expressions instead of just numbers. Or I could do f of, this is something we will do a ton of for the first couple of weeks. F of x plus h. This is a very important concept. So now, instead of doing 2x, it's 2 times. And because I'm plugging in a binomial, I have to use a parentheses for that to make sure it distributes correctly. So this black ink was just the red x originally. We're plugging in what's inside the parentheses. There it is. But you can actually distribute that too. So f of x plus h is equal to 2x plus 2h plus 3. Again, we're going to see a ton of things like this in calculus and then do other stuff with it. If you had pre-calc, you should have seen that done before. And it goes to something called the difference quotient, which is the first step of calculus. This h, we're going to end up doing something with this ultimately, but for now we leave it alone. What is it? We'll talk about it later. Piecewise-defined functions. They look something like this. F of x equals, then you get a little curly bracket. Now, not all textbooks and teachers do this curly bracket. Sometimes you'll just see it, 2 things stacked on each other. So let's say 2x plus 3 here, and then, I don't know, 17x squared minus 11 here. This is still a piecewise defined function. But I really do prefer, and thankfully our textbook does as well, I like to have that curly bracket to just emphasize that these are coupled, these are going together. But this is not all the information. You can't just say it's equal to these 2 things. It would make no sense. You have to give limitations. You have to give restrictions on them. So you might say, all right, well, it's this thing when x is less than 0, and it's this thing when x is bigger than or equal to 0. So if I wanted to do f of 1, I would use the top, right? And I say right because I wasn't paying attention, but that's, I'm emphasizing here. That says to use when x is less than 0, but 1 is bigger than 0, so no, that's not right. We use the bottom. So that would be 2 times 1 plus 3. I'm going to skip the color change, which we already know is 5. And I still did it, didn't I? Right? We're not using the top. We're using the bottom. 17 times the 1 squared minus 11. We're supposed to use the bottom because we're using the bottom when x is bigger than 0. And 1 is bigger than 0. 1 squared is 1, so that's 17 minus 11, which is 6. So f of 1 is 6. But if I wanted to do f of negative 1, then we would use the top because negative 1 is less than 0. So that would be 2 times negative 1 plus 3, which is negative 2 plus 3, and that's positive 1. So f of negative 1 is positive 1. And when you end up graphing these, I'm not going to do the graph of this particular one. What they end up looking like, and they don't have to be lines, they can be curves, they can be anything. Sometimes you'll have one that does this, and then maybe you have an open circle here. And then you have a closed circle here, and then it does this. So piecewise defined functions are for when there's a radical change in how this thing operates at some point in time, and some point in the x values. So we're saying, all right, originally the function is doing this thing, but then all of a sudden something drastic changes, and now we're up here and we're dropping. Maybe this is kind of like the stock market before March because of, well, you know what. So we were going up pretty well, not in a linear fashion, we were going up. And it didn't jump up here all of a sudden, but all of a sudden coronavirus hit and people were freaking out and panicking and they started selling, so that it dropped. Again, I'm not saying this right here is the stock market. I'm just relating it to that. It was kind of discontinuous in how all of a sudden it just changed directions. But they don't have to be disjointed like that or discontinuous. You can have them. You can have an, you draw this one and you make an open circle, and then when you draw the other one, you might end up with an with a closed circle, and then you do this. This left one is known as discontinuous because you have to lift your pen or pencil or marker or whatever off the paper or tablet and then go up here. But this one, where it has that drastic change, it's still connected. This is continuous. There's also the idea of one of these being differentiable or not, or both of them being differentiable or not. We'll get into that later, what that means, but that's a later chapter. I know that's a terrible habit to have. Domain and range, interval notation. It always goes furthest left, comma, furthest right. And the comma is always there. Then surround with parentheses and or brackets, depending on the problem. Parentheses mean included, which is a less than, greater than, or equal. It has the or equal part of it. Use brackets. I'm sorry, it does not. Less than or greater than. I had brackets in my head. I was thinking one problem ahead. I got to be careful doing that. Parentheses mean they're not included. We said that earlier. I'm not trying to lie. This is correct now. Parentheses mean not included, which means the symbol was originally a less than or a greater than, and I'll show you an example. Brackets are used when you're included. So it has the or equal to. You always use parentheses for infinities. So if I had x is greater than 5, if I was just doing a number line for this, here's our 5, greater than means we shade to the right. And because of the greater than without the or equals, we parentheses that. The interval notation though, which is going to be on the far right side, we can much more easily lift off of the number line part. Now, if you practice this enough, you'll be able to do it without graphing the number line, but this is helpful very often. So the furthest left we see shaded is 5, so that's the furthest left, comma. The arrow says we go to infinity, so 5, comma, infinity. We always use a parentheses for an infinity, and because this was a greater than, because there was no or equal, we parentheses the 5. But x is greater than or equal to 5 would look very similar, but with a bracket on the 5 because of the or equal. It is included. So that would be bracket 5, comma, infinity. These are not the only types of interval notations. You can have x between two numbers. You could have -3 is less than x is less than or equal to, let's go with 8. It's the number line. You'd have -3 on the left. You'd have 8 on the right. You'd shade between them. The -3 gets a parentheses. The 8 gets a bracket because of which ones have the or equals or not. So that's -3 in parentheses, comma, 8 in bracket. Okay, so how does that help us with domains and ranges? Well, Let's go back to an example, finding the domain and the range, but of a graph now. Did I hit enter enough? Yes, I did. And let's just keep the numbers simple here. Let's go with a -4 on the left, a +5 on the right, 10 on the top, and a -3 on the bottom. You know what, that 5 is in a bad spot. Let me just move it. There we go. Oh, I'm still on eraser. So that's our 5, and I'm going to put an open circle here. So this graph right here, this doesn't go to any infinities or anything like that. We're just finding the domain and the range. Domain is left and right because X moves left and right. Y moves up and down, so your range is how far down to how far up. So this thing seems to have a highest value at 10, and it swings down and it swings back up, but it never goes below 10, and then it swings back down. In terms of left and right, it goes from -4 all the way to +5. So our domain, again, we start at -4 and we're nice and smoothly moving until we hit the +5. So we go from -4 to 5, but then we need parentheses and brackets. Now a closed circle means included. This is having the or equal essentially. So the -4 gets a bracket. An open circle is like not having the or equals. It's exclusive. It's not included. So we can go up to 4.999999999999999, but we can't use 5. So parentheses. Notice I only used the x values. I didn't even look at the y values, the -3 and the 10. They meant nothing for the domain. The range, flip the script. We're only using the -3 and the 10 for this problem. So the lowest I see the graph is -3, and we can go up, we can go up, we can go up, and eventually we go up to a +10. So this is between -3 and 10. They have to be in ascending order. Now at the bottom, the -3, that was an open circle, so parentheses. The top at the 10, that's a bracket, so closed circle. Closed circle, bracket, same thing. I'm just kind of thinking about some stuff. Some basic curves. Or graphs. F of x equals x squared or y equals x squared. I still think you should know what these look like. This is also known as a parabola. It's our standard quadratic. It has a vertex at the origin, and it looks like that. F of x equals x cubed. Goes to the origin again, but it looks like you took the left side of the x squared and bent it down. F of x equals the square root of x. It looks like you took the parabola and tilted on its side, but to make sure it's a function, I'm gonna do something and then I'm gonna erase it. If you just tilt the parabola on its side, this is not a function because it fails the vertical line test. So what we have to do is restrict the the range. We only use the top portion of the graph. It's a very common technique when you have a transformation of a function that would not be a function. So square root of x just looks like that. Then we also have the absolute value of x, which looks like a v. It looks like you took a line and you took the left side and just bent it up, the opposite of the parabola. There's a lot of traits that are similar between x squared and the absolute value of x. They have a very similar demeanor. They have exactly the same domains and ranges. Now you can shift these, you can reflect these. I'm not going to get into that stuff. If we need it, we'll talk about it later. your quadratics. In your vertex form, it's f of x equals a parentheses x minus h squared and then plus k. And your vertex is h comma k. That's the lowest or highest point of the parabola. And then it opens up or down based on the sign of a. In standard form, actually, I believe it's called general form. I'm saying that incorrectly. Some people call vertex form standard form. I don't really like the fact that there's a standard form and a general form because there's no good name distinction. So I like calling this vertex form, and then the other one is just the other form. But the general form looks more like a polynomial. Ax squared plus bx plus c. Now the a's, b's, and c's are just numbers. It's literally the same a in the two forms. But your vertex is not seen. So the vertex form is nice because you can tell where the lowest or highest point is immediately. The general form, you can't. You have to use a formula. H, which is the x coordinate, is negative b over 2a. To find k, you just plug in the h value to get the vertex. It still opens up based on the sign of a. You can get additional points. You can use intercepts to get additional points to graph them. All sorts of good things. Now, we more often than not see things in the general form versus vertex form. We really will not see vertex form a lot in here, but you might see it once or twice. We're going to see things mostly in polynomial forms or factored forms. As a reminder, the quadratic formula. If you had me in pre-calculus, you heard me say a million times, you never get to forget it. Still true. For the same general form, so for f of x equals ax squared plus bx plus c, the solutions to this equation, if for 0 equals when you set the function equal to 0, which is also known as finding the zeros or the roots, or the x-intercepts, there's 3 names for that. The solutions to that, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. As long as you were in calculus, never forget this. Don't ever forget that. You need it, you need it, you need it. It can lead to real solutions, it can lead to imaginary solutions, rational, irrational solutions. Especially if you're not that great with factoring, or if a problem is not factorable, which like 95 to 99% of real world problems aren't factorable. It's just mainly the ones we do in math class that are. But if you try factoring something that's prime, you got to fall back on this. We're going to need this frequently throughout this course. So don't ever forget it. I'd love to give a test where this was the only question, but I can't do that. All right, we only have like 3 minutes left. Anything else that I cover would take longer than 3 minutes. So I'm gonna go ahead and call it a day there. That's gonna be pretty much it for review. If I feel the need to bring something up when it's relevant, so hey, we got this section coming up in 15 minutes, let's brush up on exponentials and logarithms, which we will do. Then I'll bring that review topic up. So again, I did not cover nearly everything from those 7 sections of review. Please go back and check those out, more or less depending on your rust level, how you feel with this. And again, you don't have to do it all now. I'm not going to set up a due date for the review homeworks. They won't be graded. That's just for your own benefit. So we'll call it a day. Thank you. It was lovely to air quote meet all of you. I look forward to talking to you in emails and such like that. I hope that this went well. I'm going to upload this. Like I said, it'll be on YouTube and the link will be in Canvas in about a half an hour. I'll post those 5 or 6 review documents from pre-calculus at the same time. And as soon as I can make the homeworks available, I will make them available. my fingers are crossed for today. I'm fairly confident I can have it done by tomorrow, but you don't have any homework due right now. We haven't even started anything. Someone asked a great question. Will I be providing reviews for the test? Yes, I will. And my reviews are very comparable to the tests. So there will be a review for every test. Now, whether it's just a document with the questions and the answers and you're responsible for the in-between, or whether I make it a MyMathLab assignment, I won't say. I like to do a mix and match. So maybe review 1 is just a PDF, maybe review 2 is an assignment. And reviews are not graded. That assignment would just be for the chapter R homeworks. So thank you for asking that. I knew there was something I forgot to mention earlier, and I'm pretty sure that is the only thing I forgot. There are reviews for tests. I will always announce tests at least a week in advance. I didn't mention that either. So thank you for bringing that up. That I knew there was a stall out earlier, and I was like, well, what did I want to mention? And that was it. Tests will always be announced at least 1 week in advance. So it's not like you're going to walk into class, quote, walk into class, and there's a test today. I'll always give you notice. You will never not know when there's a test as long as you're watching the videos. And if you see a review go up, that's a good sign there's a test coming. And tests will be posted for multiple days when they're in MyMathLab. Does the type of calculator you have matter? No, TI-84 is perfectly fine. TI-36 is good. The TI-84 is going to be a little better. I don't always allow calculators for tests. And, that's arguably harder to enforce without me enforcing the Zoom video for the test and everything. But, it's a weird semester, so I might have to be a little more fluid with that. I'm thinking things out. There'll definitely be calculator tests. There might be a no calculator test. But I recommend TI-83 and 84 if you're going to be using a calculator. All right. And if you have any other questions, just please email me, and we'll see you in class on Thursday. Take it easy. This was fun.